Hello everybody, hello, this is David Cuartielles, transmitting live from Sweden today. This is LiveCast number 10 for Arduino. And today we are transmitting this LiveCast that is sponsored by the European Commission, by the eCraft2Learn project. And we're going to be talking about the Arduino IDE. As you know, we're making this series of LiveCasts that come on a weekly basis at 7 p.m. CST, or CEST, sorry, which means Central European Summertime right now. If you're watching this from other parts in the world, you can of course watch it live, it will be a different time, or you can always watch it recorded. It's gonna stay at the Arduino YouTube channel. The series of programs sponsored by the eCraft2Learn project, they deal with basics on the Arduino IDE, and they are aimed at teachers that are interested in getting to know more on how to use microcontroller technology in their classes. Today we're going to be talking about the Arduino IDE and how to extend it, and the idea is going to be to present the desktop IDE once more, to see how libraries work, to see how you can install new libraries, how you can find information in the reference, and how can you use built-in examples. They will make a small demonstration where we're going to be using a device, and I'm going to show you this one here. And then you can see I have there waiting for you today an Arduino Uno and an LED matrix. I'm going to be trying those out. Then we will jump to the web editor. And we'll see how the web editor works in terms of how it works with libraries. We will not make a demonstration of the web editor today. We have just like images on the slideshow, because then I want to focus on how to make your own library. And this is even though today I will just make a short introduction, and maybe in the future we'll make a much more in-depth LiveCast dedicated fully at making libraries. The idea is that when you're working with students, sometimes you just want to hide the complexity of some of the tools you're going to be using in class, and you might be interested in making your own libraries. So I'm going to show you where you can find the examples of the Arduino IDE, or sorry, in the Arduino website, on how to make your own library, and we will follow it step by step, so you can then also follow it on your side and make it work. I'm gonna every now and then be checking the chat window. For those of you that are interested, we have the Arduino Discord channel that you can see up there, the URL. You can type that URL in your browser and it will open a Discord window. You can either follow it online, or you can download the app and run it in your computer or your phone or your tablet, whatever you're using. And it's also possible to follow the YouTube stream as well as chatting with us, asking any kind of questions. If you use Discord, please use the LiveCast channel. We have different channels for people to continue the conversation once the program is over. Just use the LiveCast channel so that we can just concentrate the questions regarding to the program in that one channel. Like right now there is about 20 people connected, so I'm pretty sure that if you have any kind of questions, it will be very easy to address them. So let's go back to the slides, and we'll start by talking about the Arduino IDE, the classic IDE. And the classic IDE, as you know, which is made in Java, you can download for free, and it's open source, and you can follow the development on GitHub and everything. But if you're just willing to teach a bunch of students, you might as well to just download it and use it right away. And at some point, you will come to this moment where you will think about like, okay, what if, do I have to write everything every time? Aren't there any shortcuts to just like have these blocks of code that I have to write every time anywhere? Well, that's what libraries are. Libraries are blocks of code that have been rewritten 1,000 times, and at some point somebody had the idea of, well, why don't you just put all these functions together, so that every time I need to make a project, I can just import this and I have all of my functions ready to use. And especially when you deal with special things like sensors or special actuators or whatever, it becomes relevant to start using libraries, because it makes your life so much easier. It simplifies how you access to code. Then you just need to make the effort of doing the complicated things once and then making simple things. And here in other LiveCasts, we've been using libraries at some point. Like in the previous LiveCast number 9, I was showing this complex sensor from Bitcrest, a Swedish company, that's called the flow sensor, that uses 2 different libraries simultaneously. It is common, and it will become more and more common as we go in the future, that new devices will be using multiple libraries in order to operate. So where are libraries on the IDE? And let me show you. This is the Arduino IDE here, and if you go to Files, and you see I have the IDE in Spanish, so if you go to Files, under Examples, you will find a drop-down menu, and under the drop-down menu there's going to be a bunch of subfolders. The first subfolders under Examples are the ones that belong to the Arduino examples that come by default with the Arduino IDE. Then further down they come examples for other boards that you might have, and if you continue further down, it says there is examples specifically for Arduino Uno, which are the examples that belong to libraries, specific libraries like EEPROM, Software Serial, SPI, and then further you might have other links to other libraries by other vendors. So there is a whole lot of different tools you can use. And actually, I'm not sure whether you could see the drop-down menu, because I'm not exactly sure if this was transmitted live. So if you please confirm, you could confirm on the chat whether you saw the drop-down menu when I click compile. Otherwise, I will just show you again on a different window. Because what I can see on my windows, I can see myself like moving the mouse up and down, but I don't know if you guys are seeing when I click on file here that it unfolds a drop-down menu. Can you just please check it out on the chat? And somebody answer on the chat. Let me see. No, you couldn't see it. Okay, good. That's good to know. So I know for future reference. As you know, this is only my 10th livecast, so sometimes there are things I don't realize. So I'm gonna just show you the full window. I have this one. So now you can see my desktop. And let me just check the Arduino IDE. There you can see the Arduino IDE, and in this case, there you can see it. I will do it this way instead. For those of you that might be using OBS for your livecast programs, you should know that if you just capture the Arduino IDE window, it doesn't show the unfolding menu. It might happen with other programs as well. So now you can see how it unfolds the menu, and you can see here there is the examples menu, and under the examples menu first is the different examples for the Arduino IDE, and sorry, I just lost it, that are grouped in categories. Then there's the examples for other boards like the GSM board, whatever, and then there is the standard libraries, and further down there is other libraries. And the thing here is that these are belonging to different things, and they are stored in different parts of in the computer, but we're gonna see that now as we continue with the slides. So let's go back to the slides, and for those of you that just joined the channel, the chat channel, please join us in the LiveCast channel. I'm going to type this here, LiveCast. If you just click on if you just arrive to the general Discord channel, you click on LiveCast and it will direct you straight away to the LiveCast channel. So we'll continue with the slideshow, and you see I just show you where you could find examples and so on. But the question here is what happens with where can you find other libraries? And so if you go back to the IDE and not just looking at the examples but looking at where the libraries are, just not to confuse people, they can be found under the sketch menu. And so let's go back there, and let's go back to the Arduino IDE, and one second, I just clicked the wrong now. So if you go to sketch, which in Spanish is programa, there you see there is include library, and here you can see a list of the libraries that are installed in this computer right now. And most of these libraries are libraries that come by default with the Arduino IDE. All of these that says Arduino libraries here, they come by default with the Arduino IDE. The ones that says here, Adafruit BL53L0X and Bitcrates PWM3901, those two are contributed libraries that were installed afterwards, that I did install in the last week's LiveCast program. So when you install a new library, it's going to be listed here, and the examples are going to be listed under File Examples, and there will be specific examples for whatever library. And this is sometimes a little bit confusing to people. That's why I'm explaining it here in the program, because one thing is that you could install a library and libraries might come without any examples, which is, in my opinion, is not a really good practice. If you make a library of code, you should give people some examples to learn how to use it, but eventually that might be the case. So you can still see whether the library is installed by checking under Sketch, Include Library, and so on. What happens when you click on one of these things is that it adds an include message on the program. I just make a blank program because I just have this one that is not blank. Here you can see a blank program. I will just make it larger. Here you go. So if I go to Program or Sketch or Include Library, and I say, okay, I want to include a stepper motor, and I click on stepper, you see what it did? It just added this code, include stepper. This is the way libraries are added to your code. So you could also type this by hand. You don't need to do that. It's just this just makes it a little bit easier to figure out which libraries are already installed and then just get them to run. Okay, so let's go back to the slides, and let's see what I prepared for you. So if you want to install a new library, what is that you have to do? And I will demo this later. I will just tell you how it goes and later go to the demos. So if you want to install a new library, what you do is that you go to Library Manager that you can find in this exact same menu. You just go to the menu, Sketch, Libraries, and on the first option in the Libraries drop-down list is Install New Libraries, or Library Manager, sorry. It unfolds a window like the one you see here that gives you a lot of options for different libraries you can find online, and we will search later for a library, and we will make a demonstration live so you can see how this works. But there is literally hundreds of libraries out there, and the way you add the libraries to the IDE is very simple. If you are a library creator, you make it, you publish it on GitHub, you make a release, and then you say, people, here's my library, and it automatically shows up in this list. So next time people come here, they will find it. And if you make a new release of the library, you just change it on GitHub, and people will get a notification when they restart the Arduino IDE. So it's very easy once people have the library installed to just keep updating them with new versions and so on. So, but the question is, where do libraries go? Where do libraries end up in your computer? And this is a question that people ask sometimes. And so there is two places where libraries are, not just one. There is one place for the libraries that come by default with the Arduino IDE that you can't modify, or you shouldn't modify. You can, of course, but you shouldn't, because I will alter the normal functionality of the software. And these libraries are found in the same folder as where your Arduino program is. But the libraries you download from the internet, they don't go there. And this is for safety reasons, in order to avoid any kind of accidents that you might be erasing something that should be working in your computer. You cannot really modify the folder where the Arduino IDE is installed. So it goes to your personal folders. In particular, in this case, it goes to the place where you install your sketchbook. So the place where you put your sketchbook is the place where your libraries are going to be. And in particular here, in my case, I always have my sketchbook on Dropbox, so it doesn't matter which computer I open, I can always have the latest version of my files. And this particular computer here, I have it under a folder called Development Sketchbooks LiveCast. I made a special one just for this program. And there is a subfolder called Libraries, and inside that folder is where the libraries are. So I'm going to just show you, just briefly, how you can access that. If you go to Sketch, and you can say here, include library, here's where the library manager is, okay? But if you click on show me the sketch folder, is what it says here. Show me the sketch folder, opens the navigation window, and it shows you where the sketch is. This particular sketch, I never saved it. Since I never saved it, it's under a temporary folder. And these kind of things might sometimes be a little bit confusing to people. So when you're working with your students, for example, it's recommended that the first thing they should do when they make a new sketch is that they give it a name and they save it, and it will end up in their sketchbook and nothing will happen. Because if I had any kind of accidents with this computer now, this was just in a temporary folder and I will just lose the file. So what first thing I should do is to click on save, and you see it opens a different folder, and this one is the same one as I had on the slide that contains 3 folders, and one is for LiveCast 9 and the other one is for LiveCast 10. So I just click on here and I will just name this one random sketch. There you go. And if I now click on sketch, show me the sketch folder, it now is under all of this like path. You know, this is my sketchbook, and here it is, sketchbook, libraries, and under libraries I find some pre-installed libraries. Okay, these are the libraries I installed in the LiveCast last week, if you're following the program, that are used for controlling this distance sensor. So what I will do now is to install new libraries, and so I will do this later. We'll install new libraries and you will see how the content in that folder changes. Okay, so let's continue. Oh, I'm just talking to myself, but I didn't change window, and everything I said right now you didn't see it. It's definitely not my day, I'm really sorry. I will just show it to you again. So here you go. So this is the program, and as I was saying, if you are, I will just make a new program to just replicate exactly the same thing I was explaining. This is a new program, and if I want to check where this program is saved, let's go to File, show the folder, and the navigation system tells me this in a temporary folder. As you see here, you can read temp. This means it's a temporary folder, which means, unfortunately, it is not a place I can access easily. So the first thing I should do, I will do if I'm working with my students, is tell them to save the file. So I can do it either from the menu or from the toolbar. And I can then just save it under whatever name, and I'm gonna call it random sketch number 2, since I already made one. And if I now go to file, sketch, show me the sketch folder, now you see ended up under the LiveCast 10, which is inside my sketchbook, which is the LiveCast. But this is different in my computer and in your computer. If in your computer, if you didn't touch anything when you install the Arduino IDE, this will end up in the documents folder under a subfolder called Arduino. So by default, in Windows, the Arduino IDE always creates an Arduino folder inside documents. Actually, the same thing happens for Mac, and the same thing happens for Linux. So we look for documents folder and create a folder there called Arduino, or in home if you don't have a documents folder. Okay, so and as I said then, under the libraries folder that is here is where I have some libraries installed. This is the thing I was just talking about a second ago for the other program. Okay, I will just close all of these windows and go back to the program. I will say hello to Gustavo, just connected from Mexico. Hey Gustavo, how you doing? And go back to our slideshow. And it's getting more and more exciting. Now, just to summarize, you saw we have the Arduino IDE. We saw that you can install libraries, and we saw that the libraries might come with examples. And we also saw that the libraries can get stored inside the sketchbook under a subfolder called libraries. So whatever you download ends up there. And if eventually there was a new update for a library from a developer, when you start your IDE, you will get a notification in a pop-up window, and it will allow you to go to the library manager and update it. So also something that is important is how to find help. This is a question that people think that the only way to find help is online, and not all teaching situations allow you to be online all the time. So the Arduino IDE has the basic Arduino reference offline with the IDE as an HTML. So if you have the Arduino IDE open, and I'm going to show you here, and you said, okay, I would like to find something in the reference or open help. This will be opening a browser window with the help that is locally to be found in your computer. I will just click on reference just to make it easy, and this open a browser as you see. And this reference, if you take a look at the URL up here, it says file, C, program files, etc. So this is in a subfolder at the place where the Arduino IDE is installed. And this is the Arduino reference, the same one that you have online, but locally in your computer. So if you have to teach a class and you just need the basic reference for Arduino, you don't need to be online. You have it here. So just remember this, because it's confusing for people. Sometimes they think they need to be downloading things all the time. Oh, you see, I was just looking for some ASCII art before starting the program, and you don't need to. You know, things are available there. So we continue, and as I said earlier, there is built-in examples, and there is a lot of examples, and the absolutely basic examples for the Arduino IDE, they are the ones that are in the number folders from 01 to 11, and those examples, they work typically for all of the Arduino boards. Then you might have some extra examples depending on the boards that you have. Like if you have an Arduino 101 that has Bluetooth and accelerometer, gyroscope, and some other features, then you will have some extra menus down here that will show up, especially when you select the right board. So remember this, that depending on the board you have, you will be having access to more examples that will be covering extra features that you might not be accessing otherwise. So, and we go to the demonstration. So as I said, I prepared this thing here, which is an Arduino Uno and an LED matrix. This is an LED matrix that you can find on the Arduino store, but it's a standard LED matrix that it runs with LEDs that are compatible with the NeoPixels. So you can find any kind of NeoPixels will work. And the idea is that how can you then use this? LED matrix easily? So the first thing you need to understand is that when you have something like this kinds of LEDs that we have here, they are complex LEDs. They require sending a whole bunch of ones and zeros through a cable to activate them. And so somebody has taken the time to create a library. In this case is Adafruit, which is very actively contributing with libraries to the Arduino IDE. So they created a library that allows you to control these LEDs one by one, and eventually all of them at once. So the first thing we need to figure out is whether there is any library that will make this work. And as usual, when I make a demo in my programs, I haven't had the time to rehearse. So I'm gonna take the risk, and I'm gonna be looking at whether I can find the right library to make this work. So here we are. That is the installation, and I will just open the IDE, and these are LEDs that are compatible with NeoPixel, and I will just show you what they have in the back. Is that they have a power and ground. You can connect power and ground both from any of the three cables, and one of them says that the in, which means data in, and the other one says the out. And the idea with these LEDs is they are connected in series. So you send just data to the first one, and that one sends us to the next one, and that to the next one, and then to the next one. So potentially you could add thousands of LEDs. As long as you have enough power in the system, they will work. So the way to go with this is that I need to look at whether there is any examples to use these LEDs. And so we'll just look for libraries that can run NeoPixel LEDs, which is how these LEDs are called. So I will just open the library manager. As you see here, this is the library manager, and it's in this moment in real time connected to the internet and trying to look for libraries. This is something that actually for which you need to have internet. So this does not have libraries in your computer and then you install it when you click on it. The libraries are on the internet in people's repositories, and when you connect, this goes to all of these repositories and makes a list for you, and you can download and install whatever thing you're going to use. So I will just write here NeoPixel, and you're going to see there is a whole lot of different LED libraries based on the NeoPixel kind of LEDs. So there is a lot of them. So I'm going to just take one and cross my fingers and see if it works. So for example, there is this one that is called Adafruit Neo Matrix by Adafruit. There is one here controlling single wire based LED pixels and strips and so on. So there's different libraries, especially when they are from Adafruit. They are related. They have a really good way of putting code together, and they reuse code from different libraries to make things work. So most likely the Neo matrix is like the NeoPixel but extended to do matrices. We could click on more info, and if you click on more info, it connects to, in this case, a website from the developer, and it says here in the help, Adafruit compatible library for NeoPixels matrices and grids, controls single and tile NeoPixel displays such as the NeoPixel shield, grids of assemblies like Adafruit 60 LED meter, requires the Adafruit NeoPixel and Adafruit GFX library. So this library actually does not work by itself. It requires other libraries underneath. This is very important because sometimes you might find libraries that require other things to be working. So most likely that one requires the Adafruit NeoPixel, which is the absolute basic library to make it work. So I will click on more information and I see what it says here. And it says Arduino library for controlling single wire based LED pixels and strips such as the Adafruit, etc. etc. So there's a lot of Adafruit products here. And after download it, rename it to Adafruit NeoPixel and install in Arduino libraries folder. So this is if you download it from the GitHub website. If you download it from the library manager, you don't have to do any of this. It's doing all of this work for you. Okay. We can just download it, and as it says here, then try out the strand test sketch. Okay, so let's do that. I will just install this library. I go here to Adafruit NeoPixels, and you see there's different versions, and this might be meaningful because sometimes you might have to use a version or a different one depending on what you want to do. Typically the latest one works. This thing that I just did went to the internet, went to this place, downloaded the library, uncompressed it in my computer and installed it. Okay, now this library is available in my computer, and if you want to check what it is, I can do the same thing I did earlier, and is to open this browser and go to my development folder to see where my sketchbooks are. As I said, in my computer it's a bit complicated, but in your computer will be very easy. And under LiveCasts, libraries, this thing just install one more library. You see Arduino underscore something. The one that was installed today is this one here, and this is the NeoPixel library installed in my computer a second ago. Okay, so this is very, very simple. It's automated, you don't have to do anything, and they end up in the right place. So I just need to go to examples now and see where are the examples for this particular thing. And here you have Adafruit NeoPixel, and I can just take the strand test, which is supposed to be making the absolutely basic test with this library. I will just make it bigger for you guys to see everything. And if you remember when I was showing earlier, when you clicked on the menu, the first thing is adding the name of the library. The examples already come with these different things, and it's supposed to be using pin number 6 to make it work. And here you just make it work, saying how many LEDs you're gonna have, in which pin things are going to connect to, and the type of LED. I'm gonna assume that by default is the absolute latest type of LED, and it says here 60 LEDs for real. I have a matrix that has 64. I will just connect things, so you can see me here connecting everything. It's important that you take a careful look to the cables because the colors might be fooling you. In this case, one could think that green should be ground, but no, ground is white. So white is ground, and white, I have white for ground as well. I will just unplug my Arduino board so I don't have any accidents. So white is ground, then I have purple for power and gray for signal. So I can see from this side, white is ground, purple for power, 5 volts in this case, by the way, and signal is gray, exactly, and this will be pin number 6. Okay, so here we are. As you see, the matrix is not showing anything right now. I just make sure that I have the right board, Arduino Uno, the right port, COM5, and I click on upload, and let's see if this works fine. Right now it's compiling, then I will try to upload the code. or the tension. What will happen? I don't know. It makes it to the end, and here you go. So if I had to write, like, imagine I had to write this code from scratch right now, you know, like the way you do this is that you see, okay, I have this device, and what I can do is that I can take the data sheet and see how it operates, and you have to send these ones and zeros in this order over a single pin, and then I have to send, you know, you can imagine how complicated it is. So somebody took the time, in this case, people that work with Morse, from Adafruit, to make this library and put it on the Arduino IDE to make it available for you and simplify this whole process. So this is what libraries are really useful for. So the next thing is, like, if you want to run a class with your students and use a bunch of these ones, it is very easy to just take a look at the code and see how, for example, changing the color is as easy as calling color wipe. And the function color wipe, given a certain color, it will just change the color on the thing. I will just show you here. So here you can see in the screen how it says color wipe strip, and then to 5500, that means red maximum power, green and blue no power, and that will make a right LED and so on. And this is how the program is running. So first it makes the whole screen red, then it makes the whole screen green, then makes the whole screen blue, and so on and so forth. And it loops forever with this. Okay, so I think it's pretty clear. So if you guys have any questions, by the way, feel free to ask on the chat. I'm gonna be checking the chat all the time and checking whether there's any questions and so on. Of course, there is a comment that I should change the webcam to avoid flickering. Let me just see if I can do that as we are live. This is a really good point. But there is some features that unfortunately my camera does not allow you to do. Let's see. There you go. Flicker gone. So thank you, Thessa, for that. For some reason, this computer had the default, had the wrong settings. Let's see for the other camera. Here is it. Configure video. Yeah, this one has the right settings. Okay. So there you go. So thanks for the tip. And as I said, I want to be checking the chat. So if you guys have any questions or any requests, I think Gustavo was saying that he proposes that we include them using the Atmel SAMD21 platform. SAMD21 is the chip that is, for example, on all of the new boards that work at 3.3 volts. Funny enough, Gustavo, I've tested this and it works. So at some other program, I will just show you my clocks and other things that I do with NeoPixels and the Maker 1000, so you can see how to make this work. So the library is already platform independent. What I'm gonna do is I'm gonna turn off the LEDs because they're gonna be disturbing me otherwise as I'm talking. There you go. Okay, so let's continue with the slides to see what else was in today's program. And until now, we just saw how to install a library, how to run a library, where they get stored, where the examples are, how to find help in the reference, and so on. Another question is, how does this happen for the web editor for the Arduino Create, which is the latest editor, which, by the way, I just got told is skyrocketing. People are using it all over the place. Well, libraries in the online IDE, they end up online. So the good thing is that you don't need to download them because everything happens on the cloud. So whenever you want to use a certain library, if the library is being registered, it will show up there. The cloud system is taking the libraries from the library manager. So if you manage to publish your library in the library manager, it will end up here as well, and people will just have it there. So the thing is that you can at least make them easy for you to find if you're using them all the time. So you could start the libraries and they will end up as, attached to your profile, so it will be much easier for you to find the examples that belong to that particular system. So if you manage to get the Arduino Create to work for you, which works in like 90-something% of the computers in the world, then you don't need to install any libraries. You just need to mark them so that the system will know where to find them for you next time. But the libraries are there already, so no looking for them, no installing, no nothing. Of course, if you want the examples, then you have to mark them. Okay. So now we come to the last example of the day, which is make your own library. And this is, as I said, very important, because when you want to just make things easy for people, then you need to start making your own thing. And making your own library is actually fairly easy. And we have a really good example on the Arduino website, which is written by Dave Mellis, one of the founders of the Arduino platform. And you can find it at arduino.cc/en/hacking/library tutorial. And it's going to give you all of the insights of what you need to do in order to to make your own library. So let's take a look at this. And first, well, I have three websites that I want to show you. The first website is the website that talks about libraries in general in the Arduino for the Arduino IDE. And this is the one that explains which are the basic libraries. And if you see here, this is the list of standard libraries that already come with the system. Then there is libraries that appear when you use the 101 board, the ones that show up when you use the DUE board, the ones that show up when you use the 0 board, and so on and so forth. So depending on which boards you're using, there is a set of preset libraries that are already available for you to use. But then how do you make your own library? And I have two links for this. I have a link that is the official link, and somebody has written a tutorial based on the official link, which is a community member, which is Alexander Brevik. So Alexander, we give you kudos from here for your example. I'm gonna follow the one by Dave Mellis just because it's very easy, but you can find both. So if you write on Google how to make a library for Arduino, you will want to find both links. So it's fairly easy. And I will just follow this one step by step. So the first thing is that you should just try to make the program that you want to make on the normal Arduino IDE to see what happens. And this example here, what it does is to just turn an LED on and off, and it makes two different functions to try to turn the LED on and off. So I'm going to just copy this code to just show you how it works. This whole process is going to take me about 10 to 15 minutes, which is the process of making an entirely new library. So I will start by making a new program, and I'm going to make it full screen, and I will just paste the code here. And let's revise it. First, this program, what it does is that it declares pin 13 as an output, and in the loop we see that it says send ... .. These are functions that what they do is to make the lights go on and off in different ways. So this is a Morse code program. So it's a very simple Morse code program. And if I remember right, this is SOS, right? 3 dots, 3 dash, and 3 dot is SOS. Correct me if I'm wrong. And so the function dot, what it's doing is to make the light blink with a 250 milliseconds delay, while dash makes it with a longer delay. So it's the light is on a longer time. So this is a very easy example where you see that you have two functions, and let's say that you would like these functions to be hidden from the user and just make it very easy for them to use, and eventually augment this with new functions. So we're going to do this step by step, but first let's just double check that this example works. And let's just click to this one, and if I just click on upload, first I will just save it so it ends on the right folder, and I make it here, and I'm going to call this one Morse and save. Okay, that's done. So if you take a look at the LED now, you will see that it goes 3 short, 3 long, 3 short, and then waits for 3 seconds. There you go. Take it up again. Oops. Okay, that's done. So the next step is going to require to group the functions inside a program. So how do you hide the function, so to say? Well, you will have to create two different files. One is a header file that will contain the definitions of the functions, and the other one will be the code CPP file that will contain the actual functions. So in order to do this, the way to do it is that you need to create these two functions and these two programs, and you need to put them in the right place. So where do you put them? Well, we already saw where the libraries are installed, so we could create our own library by just going to the libraries folder inside the Arduino IDE and making sure that we name it the right way. So I'll go to LiveCasts, libraries, and I'm going to make a new library here and new folder, and I can call this folder Morse, and there you go. And let's take a look at how the other libraries are done. For example, this one here, it has a source folder, it has examples folder, and it has a library properties folder. So in source you find the names, you find the actual files of the library .h and .cpp. Okay, so in my own folder I need to create a new one that is called source, and inside source I need to create two files, and I will just make a new text file, and here it is, and I will call it morse.h, and another one, new file, text file, and I will call it morse.cpp. There you go. Then in morse.h I will have to copy the definition of the definition of the library, which is this one. This will create what it's called a class, and the class will allow me to then make instances of this library and call the different functions. So here we have the complete header file, and I'm just gonna copy the complete header file. If you want to dive in depth to see how this works, please just read the website. By the way, there is a conversation going on the chat. I will just join the conversation on the chat after we're done with this example and the program is over, and help solving some of these questions you guys are having. So here, this is for the morse.h, and you need a text editor to change this. So I have, for example, Notepad++, and I can just put here the code, and I just quickly revise what this code is doing. First thing is that it defines a new class, and if you're not familiar with classes, this is the way object-oriented programming works. It defines, how to call it, a container where you're gonna add all the things inside. This container is the class, and you can make instances of the container, which means you can declare what's called objects, which is like smart variables, just to call it somehow, that will inherit all of the properties. For example, if you make something of the type Morse, you will have the dot function, the dash function, and so on. And you will see that there is a part of the definition that is public and a part of the definition that is private. The parts that are public are the parts that are going to be available for people to use in their programs, and the parts that are private are the parts that are going to be working only inside the actual library, so that people don't get access to them and cannot modify them. So the first thing here is that you see it starts by making a strange call, and this is actually to make sure that if somebody loads the library once, they don't load it the second time, because once the library is loaded, you don't need to redefine the things, and it would be a problem if there's two libraries called the same with functions called the same, because then the program wouldn't know where to instantiate the functions and where to call the variables and so on. So what this code says is, if you haven't defined a variable called Morse underscore h, then define it. And if it's defined, then the first time, then it does everything that is meant to be done here. If it's already defined, then it jumps over and it doesn't use it again. So it's just a safety measure. Then the next thing it does is to include Arduino.h. And it includes Arduino.h because this allows you to use any of the pre-existing functions in Arduino, like digital write or the serial port and so on and so forth. So this is basically a call to another library that already exists. So this is a bit meta because you're making a library that calls a library. Okay. So, and as I'm doing this, since I'm working with Windows, I just realized that my file is not called morse.h, it's called morse.h.txt, which is actually a problem because it has to be called exactly morse.h. So I'm going to just save the file, and then later I will just modify the extension to make sure it's called the way it should be called. Okay, so this just defines the shell for the thing, and as I said, this doesn't really do the operations, it just makes the thing. Just declares things so people can use it. So let's take a look at the other part of the example. And the other part of the example is declaring the different functions as they should be used. Let's just take a look directly at the final code. And the final code that I'm going to now copy in the example, what it does is that first of all it includes Arduino.h again, so that it can use any of the functions from the Arduino system, and it includes the header file for itself. And this is very important because this is how it knows which parts of this code are public and which parts are private. And then it has three different blocks of code. I will not call them functions just not to confuse the thing. The first one is called the constructor. So when you call a Morse variable, so to say, it will declare the pin as an output. And these two are functions, or also called methods. So you call dot, it will do the blink for the dot, and if you call dash, it will do the blink for the dash. And you will see that there is this funny way of calling things. It says Morse, which is the name of the class. This is exact same name as we declare in the other one. And the double dot, it means that this is a function or method that belongs to this class. So this thing is just to make sure that the compiler, when it compiles the code, knows exactly which part of the CPP file belongs to the other part. And there is a final thing that you will also find in the example that is relevant, that if you remember, here we saw that there is a variable that is the underscore pin that is private. And as I said, this function, this variable is only accessible inside here. So when you define the underscore pin variable by calling the Morse constructor, this value is set up and it remains for the whole existence of these functions. And but you cannot access underscore pin from the other parts in the program. And it doesn't need to have the underscore in front. It's just a way of writing the code, so people are following this as a good practice, so that it's easier for people to know how it's working. So I'm just copying the code. I go to the folder where everything is stored, and I open this one in Notepad++, and I just paste the code. And I save it, and now, as I said, I need to make sure that these files are not called .txt, because .txt will be a text file. And then it's when I think I need to ask the chat, because I'm not an expert in Windows, how do you change the extension? I think I have to go to Properties, and then I have to show the extensions, right? Oops, it's not like this. It's like this. I'm gonna have to search this because I'm not a Windows user, so I'm not really sure how this works. So it's kind of funny. So Windows 10 show file extensions. There you go. And this is also a problem you might find if you're trying to do this. So it's important that that you know how to do. Okay, you said that clicking F2, but if I'm here and I click F2, I cannot click the hidden extension. This is the problem. Brumla is giving me a comment on the chat. The problem is that the extensions are hidden, and I need to make the extensions seen. Okay, it's on the top of the menu. So you have to click. By default, you see Home tab where you can perform common tasks, etc., etc. File extension or hidden files. So I should just click here, I think. There you go. And I should then check the properties. No. I have to say I really don't like Windows. See, here it is. Show the extensions. Done, it's done. Okay. Yeah, yeah. If I had Windows, I would also use like show the extensions at all times. So here we go. I change the names. Yes, I want to change it, of course, and this one as well. This is a real pain. Of course, it's for security for some reasons, but it makes things very complicated. Okay, so now the files are called as they should. But if I go to the Arduino IDE, this library is not going to show because I didn't really install it. So I will have to close the IDE and open it again so that the library shows. So we'll just close the whole IDE. And this one as well. And this one as well. Done. And open it again. Here we go. And I go to libraries and let's see if the Morse library is here. It's not. So what happens is that the new libraries, they require also, if I'm not mistaken, changing some of the properties on the because there's a properties file, so I will require how to fix that. Okay, so if you take a look at the other folder, like the playground, that makes a similar example. Is not covering this up either. It's just having the old format, because there's a difference, and this is actually something that has to be updated in the documentation, because in the old format libraries, they were just contained directly. They were not contained under a source folder. They were contained directly on the main folder. So they will be more like they will be here, like this, as you see now. And if you would restart the IDE, they should show up there. I'm just making sure that this is not the case, because there's been some updates in the Arduino IDE in the recent times. And let's see here. Here it is. You see. So if you wanted to find it under another subfolder, you need to have a JSON file and so on. But here it is. So it's the Morse library. So I could include the Morse library, which is what I wanted. Okay, I just make a new file instead. And let's then finish the example as we were doing from the tutorial website. And here is how an example code will be. And I will explain it in detail so you understand. Okay, So first, it includes the library Morse that we just created. It calls only the .h file, and the .h file will, by extension, call the .cpp, and so on. This is called the constructor, which is the way you define a variable of the type Morse. And if you remember in Notepad, I will just show it to you here. Open with Notepad. If you remember this from Notepad, you see that Morse was having a variable that you will call when you were declaring the function, declaring the constructor, that is the pin number. So when you call this one, it already calls pin mode, so you don't need to have it. You don't have to do it later. And from that moment on, if you want to call the methods attached to this variable, you just need to call dot something. So it's Morse dot dot, Morse dot dash. And if this works properly, I will just save it. It will do the exact same thing it's doing right now, but with our own self-declared library. I'm going to call this Morse2, save and upload, and I keep my fingers crossed to see how it works nicely. And of course, I had to have a problem. And I think one second. Yeah, no. The definition is right. Let's try to compile it, and if not, I will just, yeah, it can't find the library. So I think the problem is that the library is gonna need to be in the subfolder. There you go. Try to compile now. No. Ah, sorry. The problem is that I declare the names with it's lowercase and not capitals. But this is going to be a problem. It should be called with capitals. This is another issue with Linux. So the file should be declared with capital letters, and the folder itself for the library should be declared with capital letters. So you should have the exact same name for the folder and for the .h file, principal.h file, and so on, if you're using this technique. Here you go. Yeah, as Brumla mentions, I think it's a naming issue, and now it's trying to compile and it's not throwing an error, so clearly it was a naming issue. Yeah. So once it's done, I just click on upload, and there you go. Okay, so once this works, basically we'll show today how a library works, how you can install an existing library, how you can circumvent some potential problems that you might find eventually. So this works, I make it work, and how you could make your own library. Then the next thing will be to add more functions to the library. How would you add more functions to the library? So if you wanted to add more functions to the library, you need to declare them both in the .h file, but also in the .cpp file. So one is the actual way the function works. So you will have to create void Morse, for example, E, if you want to just to have one that sends the letter E, or one that sends any letter and has a table, and depending on the letter, it sends the dots and the dashes. And then you need to declare the actual function name on the .h file to make sure it's called properly. So this is the technique. So you need to create a folder in libraries, etc., etc. And then the nice thing is that you could compress this folder, this library, and hand it over to other people. So let's say you made this library for your students. You could compress it. I'm going to just show you how this goes. So I will just zip it. I never did this in Windows. no, it's not zip extra time. Oh, I really don't like Windows, sorry to say. Here, compress, here you go. So then you compress it, and now they should have made a file in the folder. Oh. Okay, I can zip it because it's not, I've never used that program, so it's not registered. So here I zip it, here you go. So it's the morse.zip. So what I'm gonna do now is to delete my library. So my library does not exist anymore. If I try to compile, it's gonna throw an error because the library does not exist anymore. Exactly. So what I'm going to do then is I will install the library by including a zip file, because this would be a way that how you could create a library for your students and then just hand it over, installing all of the computers. So here you go, and I just need to go to the desktop, to my folder Dropbox, if I find it. This one, but here, development, sketchbooks, LiveCasts, libraries. So here I have the zip file. If I just add the zip file, now it will, it just added the library by itself. So what Arduino did was to uncompress the folder again. Here it's again, and if I click on compile, it will compile. So this will be the path then. You make the first program, you check that it works. Let's take a look at this. Once it works, you make the .h file, you create the class with the names of the functions, you put the private variables separately, you make the .cpp file, add your functions there. Remember to add the constructor so that it will initiate like the different things that you need to initiate, and then you make the revised version of the code. And if you want to transfer it to other people, you can zip that folder and hand it over to other people. And you can make very complicated libraries that could include multiple H files and multiple CPP files, and even make calls to other existing libraries in the same way that in our library we're calling the Arduino.h file, which is basically the basic core of the Arduino language that you can call at once. And there is slight differences between how you do this in Linux and Windows and Mac. So you might face some small issues like I just did, which is very normal, but it shouldn't be a big problem in the long run. Okay, so that was everything for today. It was a pretty okay livecast for about an hour. We learned a bunch of new things, and if you happen to have any kind of questions, please ask them now. I will disconnect the livecast and we will continue talking in the chat. There is 5 or 6 people that are asking a couple of questions, so I will see you there.